In this lesson I'm going to talk about dilations. If you look at the book definition, it gets a little confusing. You have a transformation determined by a center point C and a scale factor K. When the scale factor K is greater than 0, the image P prime of point P is the point on ray CP such that the length of segment CP prime is equal to the absolute value of the scale factor times the length of segment CP. When the scale factor is less than 0, then the image point P prime of point P is the point on the ray opposite ray CP such that the length of segment CP prime is equal to the absolute value of the scale factor times the length of segment CP. I get confused just reading that. So what I've done is I kind of made up, this is not the official math definition, but this is how I try to think of a dilation so that it's not so confusing. And this is the one that I would have written in my notes. I wouldn't worry so much about the one I have up here. I will come back to this and reference it to kind of show you where all the math is coming from, but the blue here, a transformation using a center point, similar to a rotation, and a scale factor, something we haven't talked about yet in our transformations, that may change the size and location of a figure. So basically, when we talked about reflections, we flipped it over a line, and the preimage and the image were congruent. When we translated it, we slid it, and the preimage and the image were congruent. When we rotated it, our preimage and our image were congruent. But when you get into a dilation, it may change the size and the location. So in some cases, the size is going to stay equal, meaning we're going to have another isometry, but in many cases, the size is going to change, so the dilation will not be an isometry. Now I'm going to go to Sketchpad to take a look at some of this. And what we have here is I have my center to B, the distance from the center of dilation to point B. That's right there. And then I also have the distance from the center to point B prime. That's right there. What I've done then is I've written those as a scale factor of the purple over the green. And notice I have a scale factor of 1.93. Now what I want us to look at here is doesn't change when I move the preimage around, but if I start moving the image, oops, not that point. If I move this, notice my scale factor is changing. And what I want us to notice is right here, my scale factor is 1 because the distances from the center are essentially equal. Remember that Sketchpad is going to do some rounding. When I bring that image in closer to the center, now notice the scale factor. So all these times where the image is closer to the center, notice the value of my scale factor. When I get the scale factor, or when I get the preimage to land essentially right on top of the image, notice the scale factor, it's 1. And then when the image is bigger or farther away, look at my scale factor. It's bigger than 1. Which is going to bring me back to wrong one, this one. And I'm going to go to my next slide. So what I learned here is if the scale factor was greater than 1, well, right here it's greater than 1. What are we noticing about the image? 1, the image is an enlargement. It got bigger. And 2, the image is farther from the center than the preimage. Now what happens when that scale factor was 1? Well, I come back here and remember when I got that scale factor to be 1, the preimage and the image were equal in size, they were congruent. So then the dilation is going to be an isometry because the scale factor, well, because they're congruent. The preimage and the image are congruent. The other thing is the image is going to be equidistant from the center. They're both the same distance away from the center. And then in my last one here I have, well, when the scale factor is less than 1, well, that was coming back here, less than 1. Notice it gets smaller. So we have what I'm going to refer to as a reduction. And it also gets closer to the center. So those are the 3 things that can happen with your scale factor. Absolute value can be greater than 1, the absolute value can be equal to 1, and the absolute value can be less than 1. And then what happens in those 3 different cases. Now in a dilation we can have a negative scale factor. This is something new. So what I'm going to do is I'm going to look at that. So here, notice I still have my distance from A to the center, and I have my distance from A prime to the center. And I could have measured B to the center and B prime to the center, etc. But our scale factor is not going to be any different. I still took the distance from the image to the center and divided it by the distance from the pre-image to the center. And I end up with this number this time. Now notice it's negative, which doesn't really make sense because I took a positive and divided by a positive. You'd think it should be positive. But this is how this works. Notice now this time where the image is at. It's not on what I refer to as the same side of the center as the pre-image. It's kind of on that other side, which I know doesn't make sense because you're dealing with a point and it doesn't really have sides, but I'm hoping it'll make sense in your head, kind of like it is in my head. So when that scale factor becomes negative, we just go to the opposite side of the center point for all our points. Notice here was B, well, B prime, other side of the center, C and C prime. But if you look at the scale factors, remember it was talking about absolute value. When that absolute value is greater than 1, notice it's getting bigger and it's getting farther from the center. You can tell it's farther from the center by looking at these distances. When I get that scale factor down to have an absolute value of negative, or I have an absolute value of 1, now look at, they're equidistant from the center, and if we look at these two figures, they're congruent. And then when the absolute value is less than 1, well, notice it's getting closer to the center and it's getting smaller. So here, if the scale factor is greater than 0, well, that's what we looked at the very first time, was then my image is going to be on the same side of the center as the pre-image, and if the scale factor is negative, which we just looked at, then it's going to be on the opposite side of the center from wherever the pre-image was at. And again, you have to keep that straight. And really, this is where, this all comes into play, right here. When the scale factor is less than 0, then the image, so in my sketchpad ones, that would be, say, A prime, of your A is the point on the ray opposite ray CP, which is saying, well, if we go opposite this ray, let me get this one out of the way. If I go opposite this ray, that's going this way, and then that's where that comes into play, that whole opposite ray talk. So showing you how the actual math, it does make sense, but it is, I know, rather confusing. And then that's going to conclude my lesson dealing with the dilations. I will have another one that will look at some examples.